The next one we're going to do is number 4, right? And this one, you're going to see a problem like this maybe on every single year's AP test, okay? Very, very popular these days. So f is a continuous function defined in a closed interval -4 to 6. The graph of f consisting of 4 line segments is shown above. Okay, what's important here is f is continuous, okay? But the most important thing that we read here is that the graph of f is shown above. You want to highlight this, and when it comes to these types of problems, it's very easy to get lost in, wait a minute, what is what, okay? So it's very important to keep track. This is the graph of f, so highlight that, whatever. Okay, g is another function. G is the integral, this is g. G is the integral from 0 to x, f of t dt. So what does that mean conceptually? What is g? What's another word for integral? Or also starts with an area. G is the integral is area. So g is the area under what curve? F from 0 to some number. So let's explore for a minute. G of x is the integral from 0 to x, f of t dt. Okay, that's g of x. G of 1, okay, now what happened? X got replaced by 1. So it's 0 to 1, f of t dt. That means it's the area between the curve of f and the x-axis from 0 to 1. So it's that area, okay? And if I were to do like, what's g of -4? The integral of what? From where to what?
0 to -4.
0 to -4. Exactly 0 to -4. Then you flip it. Okay, so that's how g works. Okay, let's see how we're going to use this. On what open interval is the graph of g concave up? What? Where did that come from? Okay, so let's think about concave up. What does it mean that something is concave up? It's what is positive? Nope. One more. Second derivative. The second derivative is positive. Okay? So we want g double prime of x to be greater than 0. Okay. So this is g. Okay? G prime of x is the derivative of this, which is just f of x. That's what I'm getting at. So g prime is the derivative of this, and the derivative of an integral is always the inside. So that's f of x. G double prime of x, then, is f prime of x. Okay? So, if I want g prime to be positive, that means I want f prime to be positive. And if this graph is f, what does f prime represent? The slope. Or the derivative, yes, which is the slope. So, on what intervals is g concave up? On what intervals, I don't have anyone on there today, so. Okay. On what intervals is f prime positive, or where do you have increasing slope? So here and here, right? So that's from, so I say it's concave up. So G is concave up on -4 to -2 union 2 to 6. Yes? Why? It says give a reason. Because f prime of x, which is g double prime of x, is positive. Okay? So this is your answer here. Okay? let P be the function defined by g of x times f of x. Find P prime of 3. Okay, so P of x equals g times f. If I want to find P prime of x, what rule do I have to use? Starts product rule, because it's one function times another function. So the product rule says it's the first times the derivative of the second. Okay? So g of x times the derivative of the second plus the derivative of the first times the second. Okay. Okay, so here you'll probably be given 1 point for using the product rule for the derivative. Then, now we want P prime of 3. So this is g of 3, f prime of 3, g prime of 3, f of 3. Okay, now, g of 3, let's go up here. G of 3 is from 0 to 3, area of f of t dt. So from 0 to 3. Okay? So, so that's this area and this area. Okay, so always remember when you're looking for area, it's the area of the region between the graph and the x-axis. Don't go taking like extra parts. Okay, so look at this. Do you see how this triangle is the same as this triangle? One is positive, one is negative, so they cancel each other out. That means all you've got left is that trapezoid over there in the blue, which has an area of 7 over 2. Okay, so g of 3 is 7 over 2 times f prime of 3. F prime is the slope of f. At 3, what's the slope here? 1. Plus, what was g prime of 3? Okay, you have to go here to your little flashcard. G prime is f, so that's the same as f of 3. F of 3 is how much? Negative 3. And then f of 3 again, negative 3. So altogether, that's 11 over 2. Okay, you see, not a calculator in sight for these. That's just the area of that blue trapezoid over here. So half b1 plus b2 times height. Okay, part C. Okay, C is an interesting one. Okay, so C, limit as x approaches 2 of g of x over this. All right, so let's plug in 2 in the numerator here. That would give you g of 2. What's g of 2? It's 0, right? Because that's the area that cancels out. So, okay, that's 0. Okay, so then let's plug 2 into the denominator. What do you get? 0 over 0. Oh my God, what do we do when we have to find limit? L'Hopital's rule. You see how it sneaks its way in. So, but first you have to establish that you can use L'Hopital's rule. And here is the way we say that. So, you want to say the limit as x approaches 2 of the numerator g of x, g of x, is 0. The limit as x approaches 2 of x squared minus 2x is 0. Okay? And now that's enough for you to have like the right to use L'Hopital's rule. Now you have to say, well, you have to say this first. Now you have to say using LH Okay? This is the limit as x approaches 2. And how do we use L'Hopital's rule? It's the derivative of the numerator over the denominator. Okay? And what was g prime again? F of x, right? G prime up there is f. So this is f of 2. Yeah, which is, let me just write that. Negative 4 over 2, negative 2. Okay, so isn't that cool? This is the test that your friends took that are in BC this year. Yeah, that's cool, isn't it?
Wait, yeah. For the test, they have to take every single limit?
Yeah, this was their test.
But I thought there's one FRQ.
No, 6 FRQs.
There's 6 FRQs?
Eventually, yeah, like a year later.
Do the other math teachers also do it? Or is it just
this is a negative, huh? All right, so we're good here. So this blue negative 7 over 2, that's a negative. So that is 11 over 2. Let's move on to D. D says, okay, find the average rate of change of G. Okay, average rate of G, average rate of change, that's, you know, f of B minus f of A over B minus A. Okay, on the interval negative 4 to 2. Okay, that's a stop there. Then there is like some other stuff. Does the mean value theorem guarantee a value, blah, blah, blah? You know what? I'm not even going to worry about that. I'm just going to do what the first sentence told me to do. Okay? So let's find the average rate of change of G. So that's going to be G of 2 minus G of negative 4 over 2 plus 4, 6. Okay. So let's go back up here. Well, G of 2, we did that a couple times, is 0. Now let's do G of 4. I'm sorry, negative 4. I'm going to do it here. G of negative 4 is 0 to negative 4 f of t dt. Well, that won't do. The limits are all switched. So that's negative 4 to 0 f of t dt. Okay? So that is this area here. Okay, from negative 4 to 0. And so if you split it up, okay, this part is 6 and this part is 10. Okay, because you have a triangle and a trapezoid. So this is negative 16. Okay, so we're going to come back here and put in the negative 16 over 8. I don't know, because it's 2 plus 4 and then it's 6. You know what I meant. So that's 8 over 3. Okay, now you think to yourself, wait, there was more to that. So let's go back. So this is the average rate of change. Does the mean value theorem guarantee a value C between negative 4 and 2 for which G prime of C is equal to this average rate of change? Justify your answer. Yeah. You're sure? Look at it. Yes. Yes. Which means also continuous. Okay. So what is the mean value theorem? Mean value theorem says there has to be a point, okay, blah, blah, blah. If blah, 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 then there has to be a point C such that G prime of C is equal to G of B minus G of A over B minus A. The mean value theorem says if blah, blah, blah happens, then there has to be a point where the average rate of change equals the instantaneous rate of change. And the premise is, the hypothesis is, if f of x or g of x is continuous. Okay? If it's continuous. So yes. Okay. So we're talking about g. Is g differentiable? Were we able to find the derivative of g? Yes. If g is differentiable, it implies that it's continuous. Yes. So since g of x is differentiable, it is also continuous. Therefore, mean value theorem applies. So it says f is continuous, not g. Yeah. Okay? Okay. Yeah.
This also might be
Yeah.
0 minus negative 16.
Yeah.
Plus equal y plus equals 0.
0 minus negative.
There's nothing that, but there's nothing. Minus. Yeah, minus, but there's nothing. 0.
0
Why can't
plus 16 is what?
Oh, why is it?
It's 0 plus 16.
16, but it's not plus.
It is. If it was plus instead of a negative,
right.
it would be negative 16.
No, because there's a negative here because we switched it. Here we switched.
Okay.
Okay, let's go to number 5. Okay. Consider the function y equals f of x, whose curve is given by the equation there, for y is greater than 0. Show that dy dx is this. Okay, so basically we have to take a derivative of this, and they gave us the answer. We just have to show that that's what you get. Because this is an implicit function, you can't solve it explicitly for y, you have to use implicit differentiation. So remember how implicit differentiation worked. It was basically the chain rule. So by implicit differentiation, if you take a derivative of that first term, right, it would be 4y dy dx, chain rule, right? So you bring the 2 down, 4y times the derivative of the y, okay? The derivative of minus 6 is 0 equals, now here I have a product rule happening, right? So u is y, v is sine x. So u v prime, so y cosine x plus u prime dy dx v. Okay, now we need to solve for dy dx. So bring everything to the same side. 4y dy dx minus dy dx sine x equals y cosine x. Take out the dy dx. What do we get? 4y minus sine x. Okay? Yeah. So now dy dx is y cosine x over 4y minus sine x. See? We proved it. I mean, we showed it. That's it. Right. So what they would like to see is that you use implicit differentiation correctly. And then the rest is algebra, so they're not really going to take a lot of points for that. So it'll just probably be like 2 points for this. Yeah.
So would it be okay if I took away that third step?
Yeah. Okay. So that's part A. Part B. Write an equation for the line tangent to the curve at the point 0, comma root 3. To write any equation of a line, you need a slope and a point. Slope is this, but it needs to be evaluated at that point, right? So for part B, we're going to say, okay, dy dx evaluated at 0, comma root 3. Okay, so root 3 cosine 0, 4 times 0 minus sine of 0. Root 3 over, oh, sorry, it was 4 times y, root 3. So that's just 1/4. Okay, now slope at a point. The point is 0 comma √3, right? So y minus y1 is equal to m x minus x1, 0. So y equals 1/4x plus √3. Okay? Cool? Either is fine. Okay. Next, C. What does C say? For the interval 0 to pi and y is greater than 0, find the coordinates of the point where the line tangent to the curve is horizontal. What does it mean if the line tangent is horizontal? dy dx is 0. Okay? So, dy dx, which is our lovely function that we just found, that they told us to find, is 0. So I just take the numerator, set it equal to 0. Y goes away, right, because you can divide both sides by y. Cosine of x is 0. X is pi over 2. Okay, now let's check. Are we done? Is this what they wanted? No, because they wanted the coordinates of the point, not just x. How am I going to get y then? Plug it in where? The original. Plug it in here. So 2y squared minus 6 is equal to y sine of pi over 2. Oh, look, sine of pi over 2 is 1. So this is 2y squared minus y minus 6 equals 0. 2y plus 3, y minus 2 equals 0. Y is negative 3 over 2 and 2. But y had to be positive, remember? It said so here. Okay? So I just take this one. So pi over 2 comma 2. Okay, so that's the answer there.
For the factoring, why wouldn't it be 2y plus 3 times y minus 4?
Because you want it to be a negative 6.
But are we... Oh.
Yeah, that's the last period thing. Okay, so D. Okay, determine whether f has a relative maximum, a relative minimum, or neither at the point found in part C. What is the point found in part C? This is where there is a horizontal tangent. Okay? So if you have a curve that looks like this, there is a horizontal tangent there and a horizontal tangent there. But one of those points is a relative max, one of them is a relative min. So how can you tell if it's a relative max or a relative min? What's the concavity? Concave down, concave up. You remember that, right? That's the second derivative test, which says if at a point the first derivative is 0 and the second derivative is positive, it's a minimum, right? If it's concave up, it's a minimum. If it's concave down, it's a maximum. So I need to find, is d squared y dx squared greater than 0, equal to 0, what? Okay? So let's find that. Let me do it in a different color. So d squared y dx squared. Okay. This is like quotient rule, right? So low d high. What's the derivative of the high? That's a product rule, right? So we're going to do uv prime. So negative y sine x plus u prime dy dx cosine x. So low d high, take high d low. Okay, so y cosine x, that's the high d low for dy dx minus cosine x. Square the line and cross the cross the line and square the low. Now, I need to evaluate this at what? The point that I just found. Pi over 2 and 2. So don't simplify, just plug it in here. So 4 times y is 8 minus sine of pi over 2 is 0. And then here, negative y, so negative 2 times sine x is negative 2 plus dy dx cosine x. What's dy dx at this point? At this point. Dy dx is 0. Right? That's where you had a horizontal tangent. So 0 minus y is 2. What's cosine of x at this point? Cosine of pi over 2? 0. So that all goes away. It's just 0. All over 4 times 2, 8 minus 1 squared. Okay, so this gives you negative 14 over 49. But all I care about that is that that's negative. So, since dy dx is 0 at this point, at pi over 2, comma 2, and d squared y dx squared is negative, okay, there is a what? So if the concavity is negative, it's concave down, so there is a relative maximum. Okay, and I think we'll stop here today.